All right, ladies, for our second part 2 of the 7.1 videos, we left off with talking about how we would have to make sure on the previous example that 83% of our households was represented by 83 of our numbers, so either 0 to 82 or 1 to 83, while the remaining numbers represent no internet. So that's really the toughest type when it's not a nice even round multiple of something like 5 or 10 to work with when you have to use double digits and so on. So I want you to pause the video here in just a minute and think about how you would assign digits for this particular situation. I have 50% of households in a town have dial-up, 20% have no connection, and 30 have either a cable or DSL connection. So pause the video here for just a minute. Think about how you would assign your digits, or if there would be some other type of device that you use other than digits. Okay, once again, this is not the only possible correct answer. I chose to do digits since I have 3 options here and they're not equally likely. So for instance, a die would not work if there were 3 equally likely options. I could assign 1 and 2 to be one outcome, 3 and 4 to be another outcome, 5 and 6 to be a third outcome. But since they're not equally likely, that won't work. I would have to find some other device, if not using digits, where half of my outcomes could be represented by having dial-up. So in my case, half my digits, I chose 0 through 4 to represent dial-up. Then 20% more of my digits would have to represent no connection. And the remaining 30% would have to represent cable or DSL connection. So that altogether that would make up all the possibilities. Okay, let's do one more full simulation together, and then I'm going to have you take a look at an activity in the classroom. So here's another example. A couple plans to either have children until they have a girl or until they have 4 children, whichever comes first. How likely is it that they will succeed in having a girl? So this one's a little bit different in that we don't have a set number of trials like the one about the free throws. We have 2 options. Either they're going to continue having children until they have 4 children, or they're going to stop when they have a girl. So first things first, define your assumptions. Even though it's not stated specifically in here, we would assume that there's a 50% chance of having a girl each pregnancy. Therefore, and I should have also stated that each of the births is independent. And that is important because, for instance, if you had twins, it could be more likely. For instance, identical obviously is if one is a girl, the other one has to be a girl. If one is a boy, the other one cannot be a girl either. So I would want to state these are single births. Births are independent, meaning the gender of one child does not affect the gender of the other, and so on. Because of that, I would assign digits 0 to 4 to represent girls and 5 and 9 to represent boys. You could do evens and odds again, or you could have the numbers switched. Okay, so a number of different correct ways you could do it. Then I'm just going to pick up on my table where I left off on the previous problem. You could really start anywhere. Okay, so I have my trials highlighted in different colors. So for the first trial, first number in that third row where I'm starting is a number 2, which represents a girl. So that couple, if this is their trial, is actually going to stop after 1 child. Their first child was a girl, they're going to stop having kids. The second trial got a 6 first, which is a boy, and then a girl, 0. They're going to have 2 children, they're going to stop. Then the next trial has a 5, 0. That's the end of that trial because the 0 is a girl again. 8, 1. I stop there. 5, 8, 6, 1. On that 4th child, I was able to get a girl. Okay, which, if you think girls, boys being equally likely, it makes sense that quite a few of our trials only took 2 tries, 1 boy, 1 girl. In this case, this last case, I ended up having to, I had all 4 children. I did end up having a girl in that trial as well. You could also have one, if I kept going, where I would have 4 numbers in a row that were all between 5 and 9, representing the couple not having a girl in that case. Okay, and then after I do my simulations, I'm going to make my conclusion statement. So in my 5 trials, the couple was able to have a girl 100% of the time. Okay, if it was only 4 out of 5, then I would say that happened 80% of the time. And then follow-up question, on average, how many children will the couple end up with? So this could be done with the same assumptions, even the same simulated trials, but instead of looking at whether or not I obtained a girl, now I'm looking at how many children did I have in each trial. So in the first trial, I finished, remember, with just 1 child. The second, third, and fourth trial, I ended up with 2 children, and that last trial, I ended up with 4 children. So add them up and divide by 5 to find the average, and I would be able to conclude that on average, a couple with this particular family plan would end up with 2.2 children. That would not need to be rounded, because remember that we're talking about on average. We're not talking about any one family ending up with a fraction of a child. Okay. What I'd like you to take a look at is an activity posted separately in OneNote about hiring discrimination. To summarize it for you, there are 25 junior pilots who are looking to become pilots, to become captains. In those 25 pilots, 15 are male and 10 are female, and there's only 8 positions available. So they are going to use a lottery process to determine who is going to be chosen. In other words, names are going to be chosen out of a hat. So all the names are written on papers, mixed up, and drawn out. When those 8 spots are announced, 5 are female and 3 are male. So some people are complaining that it must have been rigged for there to end up being more females chosen than males chosen if it was truly by chance, just because there are more males in the slips of paper that were originally put into the hat. So what I'm going to have what I've asked the sub to do is pull out the beads out of the press, out of the wooden cabinet in the room. There are some beads. You should have, looks like just 25 beads in the bag. If you have more than that, that's beads for a different activity. Take a look at your individual bag, figure out what color represents male, what color represents female, just based on the 15 male, 10 female in the original setup. And what you're going to do is draw out 8 beads at a time. Okay, so just take out 8 at a time. You're going to do it without replacement, meaning I'm not going to draw 1 bead out and look at it and put it back, because I can't have one person chosen more than once. So after I take a bead out for each trial, I'm going to keep it out. So I'll have 8 beads. I'm going to count how many of those are the female color, whatever color that is, and add it to the dot plot of my own data. And then if I can have a volunteer go up to the whiteboard at the front of the room, draw an axis for the class data, and if everyone can put their 5 data points for how I asked you to carry out 5 trials of that simulation, how many females you randomly chose out of your 8, then we can see how likely it is that 5 or even more just happen to be female by coincidence, by randomness or chance. So once again, take 8 out at a time, count the females, put them back, shake them up, do another trial of it, and let's see whether this was rigged in some way, whether there has been some discrimination involved, or if this was something that just happened by chance. Please let me know if you had any issues carrying out any of the instructions. You're welcome to email me, and otherwise we will catch up and discuss any questions that you have when I see you next week. Enjoy your weekend.